The second immediate inference we'll talk about here is obversion. So when we avert a proposition, we'll do two things. One, we're going to change the quality of the proposition without changing the quantity of it. And two, we're going to replace the predicate with the term complement of that predicate. So a complement here, when we're talking about a term complement or something that's complementary, we're basically talking about everything that is outside of a particular class. So if you have class B, the complement of class B would be non-B, everything outside of it. If you have, to be more specific, if you have a class and the class represents cars, or the class of cars, then the complement of that would be all non-cars. So planes, trains, elephants, that sort of thing. Anything that is not a car would be a complement of that initial class. So again, to go through each individual one of the propositions that we've talked about here, to begin with the A proposition, when we avert that here, we're going to change all A are B to no A are non-B. So we're changing the quality here, and we're taking the predicate class and switching it with its complementary class. So if you say something like all cats are mammals, then the complement of that statement is no cats are non-mammals. Sort of self-explanatory there. And as we can see then there that according to the Venn diagrams, we're covering the same exact area. And so what's going to happen with our A propositions is we're going to say that the truth value of the obverted statement will be identical or will be the same as the given value. And really what we're going to find here, just to make this quick, is that when it comes to all four kinds of propositions, it's going to be the same idea. When you avert that proposition, it's going to have the same exact truth value that it had initially. So again, we can see this here with the E statements. No A's are B's, for example, no cats are reptiles, if we were writing about this, is the same, when we avert that, has the same exact truth value as all cats are non-reptiles. Okay. So that's, again, fairly self-explanatory on that point. So let's talk about the other two statements just to show you what it looks like on a Venn diagram here before we move on to the next inference. So if we're dealing with our I and our O, so sum A R B should look like this. You have at least one thing that is identical with both here, and then the obversion of this would be, in this case here, sum sum A are not non-B. Okay. And then the obversion of the O statements here will be that sum A are not B, averting it, changing the quality here, sum A are non-B. All right. So again, if we go back here to our our I statement, it's the same idea. If you're saying some, for instance, some A's or some cats are not white animals, are not non-white animals. You're basically saying here, so you have, it's basically the same exact where you're putting the X in the Venn diagram here. You're saying that it is not part of any class of the non-B, anything that's outside of the B class. Okay, so it is actually part of the B class. Likewise, if you're saying some A are not B, that's the same thing as saying some A are non-B. Some things are outside of the class of B. or some A's. Something of the class A is outside of the class of B here. So once again, with both, when you avert the I and the O statements, it does the same exact thing. Truth value of the given statement will be the same value as the averted statement. So aversion is fairly easy to remember in terms of like what about the nature of the truth values. After aversion, the trick is just remembering how to do the aversion with the two-step process here.